All right, what we're going to be learning in this lesson is hypothesis testing. And before we get to the procedure of hypothesis testing, I want to give you some definitions and some understanding regarding two important concepts, and that is the two ideas of the null hypothesis and what's called the alternative hypothesis. I'm going to give you definitions for both, but first we're going to look at some examples. We're also going to look at the concept of a p-value. So we're going to look at two examples. They're fictional examples, so please take them as fictional. Example A is suppose that there is a company, some kind of pharmaceutical company, and they're making a new medicine that relieves a headache. Okay, kind of like aspirin and Tylenol and Advil. So it would be a competitor for aspirin, a competitor for Tylenol, a competitor for Advil. So, but it's a new medicine, doesn't have a name yet. Now this company that is making the new medicine, they think that their new medicine is better. They think it's better than aspirin. They think it's better than Tylenol and better than Advil. Now suppose that those medicines, aspirin, Tylenol, and Advil, suppose those medicines make a headache go away in about 30 minutes. We call that an industry average. Now, let me clarify that this is a fictional situation. I'm making this up. I don't know what the real number is, okay? So, but let's just suppose that most people understand, or at least in pharmaceuticals, that they understand that headache medicine maybe makes a headache go away in about 30 minutes. But this company with the new medicine, they claim, remember, consider this word, they claim that their new medicine will relieve a headache in less than, that's important, in less than 30 minutes, okay? So that's our first example that we're going to work with. All right, here's example B. This is our second example that we're going to work with. Suppose that there's a biologist, and that biologist is an expert in rodents. So we're talking rats, mice, squirrels, all kinds of other things, rabbits maybe. And this biologist goes down to Costa Rica for a few years in order to do research, biology research. Costa Rica is, my understanding, a great place for biology research, okay? Now, while he is in Costa Rica, he discovers a community of rats in nature. But when he observes those rats, because he knows rats very well, but the more he looks at those rats, he thinks that they are very different than other rats, okay? So he knows what rats are like because he's an expert in rodents. But he's looking at these new rats, and he says, well, they're very different. They're different than what I used to see with rats. I don't know what it is, but there's something different about them. So I'm going to give you definitions for null hypothesis and for alternative hypothesis. And you see this symbol here. This is a capital letter H with a little subscript of a 0. We often call this either H0 or H0 or H sub 0, or we just say the null hypothesis. The alternative hypothesis is a capital letter H with a subscript of either an A, capital A, or a lowercase a, or maybe a 1 or something like that, okay? And these are the only two kinds of hypotheses. When we're doing scientific research, we always start with what's called the null hypothesis, and then what we think might be different about the world or different about the science, we call that our alternative hypothesis. Okay, so let me give you some definitions for these. A null hypothesis is the standard assumption that the population we're studying is no different than other populations in the absence of statistical support. All right, so here's what it's saying is the standard assumption. That means that we're going to assume the null hypothesis is true. We're going to assume that it's true when in the absence of statistical support. So up until we do actual statistical analysis, our assumption is going to be that the null hypothesis is true. And what is the null hypothesis? The null hypothesis is the assumption that the population that we're studying is no different than other populations. And so when we talk about the headache medicine, if most of the headache medicines make headaches go away in 30 minutes, then what should we assume? What should we assume in the absence of statistical support? What should we assume about the new medicine? Well, our assumption, it should be that the new medicine is no different than all the other medicines. So we're going to assume that the new medicine makes headaches go away in 30 minutes, just like Advil, just like Tylenol, just like aspirin, okay? Or what about our rats? Our new rats, should we assume that they are not regular rats in the absence of statistical support? Well, no. Our null hypothesis, our standard assumption, should be that these rats are no different than other rats. So we'll put here traditional rats, and our new rats, okay, we're going to say that they're the same thing. We're going to say that the new rats that the biologist has seen, they are traditional rats. We're going to assume that they are no different than other rats until we have statistical support. And so we're going to call that the null hypothesis. Now let's get a definition for alternative hypothesis. An alternative hypothesis is the idea or suspicion that the population we are studying is very different from other populations. All right, so let's think about this medicine, okay? We have this new medicine, okay? Now, the null hypothesis is that it makes a headache go away in equals 30 minutes, okay? But this company that has made this new medicine, they have a different idea, or they have a suspicion that is different than the null hypothesis. So this is an alternative hypothesis. They suspect, or they have the idea that their new medicine can make a headache go away in less than 30 minutes. And so the null hypothesis would be equals 30 minutes, while the alternative hypothesis would be less than 30 minutes. Or what about the biologist? So we have regular rats, or let's say our new rats. Our null hypothesis is that the new rats are the same as all rats. So there are no new rats. The new rats are just all rats, okay? They're equal, okay? But this biologist has a suspicion. How? Well, he's been watching these rats, and there's something different about them. And so he thinks that the new rats are actually different than, that means not equal to, all rats. And so his alternative hypothesis is that the new rats are not equal to all rats. Not equal is the same thing as saying different, okay, or very different. So he thinks the new rats are very different from all rats, and that's why this is the alternative hypothesis. So whenever we're doing a hypothesis test, what we're typically doing is we're testing against the null hypothesis. We're trying to find out whether there's enough statistical evidence to break free from the null hypothesis. And if we break free from the null hypothesis, then it shows support for the alternative hypothesis, okay? So we're always testing, doing a test of the null hypothesis, okay? And so we use a statistic called a p-value, and that p-value is referencing a test of the null hypothesis. And so a p-value of a test of a null hypothesis is the probability, assuming the null hypothesis is true, that the test statistic And now we've already talked about the test statistic in the previous videos, that the test statistic will take a value at least as extreme as that actually observed. So when we're testing a null hypothesis, what we do is we calculate what is called a test statistic, which you learned how to do in a previous lesson, or at least you learned how to calculate one kind of test statistic. And here's the idea. Typically, if we were to take the test statistic, okay, so this is going to be a number, okay, statistic, okay, and if the test statistic is close to 0, okay, if it's close to 0, then usually the null hypothesis is supported. The null is supported, okay? So the closer that the test statistic is to 0, then the null is usually supported. But if the test statistic is far from 0, oftentimes like 4 or 5. Now it may have to be more than that, but especially when you see a test statistic that's like 27 or 93, that's really far from 0. When the test statistic is far from 0, usually the null hypothesis is not supported. Usually the null is not supported, okay? And so when that happens, we often say that we reject the null hypothesis, okay? So here's what the p-value is saying. It's saying that if with our statistics, now remember, this is just coming from a sample. So based on a sample, if based on a sample, we get a test statistic that is far from 0, okay? But what if we know that the null hypothesis is definitely true? Then what is the likelihood that it will not be supported? It's very low. And so a low p-value means there's a low probability that we will get a test statistic that is far from 0. We are far more likely, if the null hypothesis is true, we are far more likely to get a test statistic that is close to 0. So if we do get a test statistic that's far from 0, since there's such a low probability of that happening, it may indicate that the null hypothesis is not true. And that's typically what we're trying to do in hypothesis testing, okay? And so that's it for our definitions of null and alternative hypothesis and an introductory brief description and definition of a p-value.